Hello everyone, and welcome to TAIYO Yuden's Bluetooth 5 Throughput demo. As you may already know, one of the key features in Bluetooth 5 is the new 2 megabit per second PHY. That is twice the over-the-air bitrate of version 4.2. And as a result, developers are wondering what kind of throughput can you get with this new PHY. So in this video, we're going to measure the throughput capabilities of the new TAIYO Yuden Bluetooth 5 modules. Keep in mind though, that there is overhead in sending data. So in terms of actual payload, throughput is always going to be less than the over-the-air bitrate. Before we do the demo, let's have a quick look at the 3 new Bluetooth 5 modules from TAIYO Yuden. All 3 modules are based on Nordic Semiconductor's powerful nRF52832 chipset. And to help you get to market quicker, these modules are already radius certified for use in the US, Canada, and Japan. First is our ultra-small module, the EYS HSN ZWZ. At 3.25 by 8.55 by 0.9 mm, it's the smallest module in our lineup. Next is our EYS HJN ZWZ, which is basically the same as the EYS HSN ZWZ, but with a bigger footprint. And finally, we have the EYS HCN ZWZ, which measures 9.6 by 12.9 by 2.0 mm. This module is bigger because it comes with the 32 kHz crystal, the LC for the DC to DC, and it has more IOs. Okay, now let's have a look at our throughput demo setup. We're going to use a Windows PC with TerraTerm, which is just a terminal emulator. We'll also use our EBS HCN ZWZ eval board and our EBS HSN ZWZ eval board. And then we're going to send data between the 2 boards and measure the throughput. In order to measure the throughput, we're going to use the ATT MTU Throughput Sample app from the Nordic SDK. For this demo, we're using version 13.0.0-1.alpha of the SDK. And the sample app can be found in this directory. In order for the sample app to work on TAIYO Yuden's eval boards, we need to replace the main.c file of the sample app with the one from our GitHub page. The sample app is written for Nordic's eval board, and it uses buttons that our eval boards do not have. So to make the app work with our eval boards, we need to use the main.c file from our GitHub page. It's just a modified version of the original main.c so that key presses via TerraTerm are used instead of button presses. The next thing to do is just compile the app and flash it into the 2 eval boards. If you are using Kyle, the project file to compile is in this directory. Okay, so I already have the boards flashed and connected to the Windows PC. So let's go ahead and launch TerraTerm for the first eval board. Select serial and then the COM port. The first one is COM14. Then set the baud rate to 115.2. Then we repeat the same thing for the second eval board, but this time for COM19. Next, press the reset button on both boards. Now you should see 2 options on both terminals. Option 1 for board tester and option 2 for responder. We'll select 2 for this terminal. It doesn't really matter which terminal we pick. We just need to make sure one board is configured as a responder and the other board as a tester. And then for this other terminal, we'll select 1 for tester. But before we run the tests, let's change the connection interval by selecting 2 to adjust parameters. And then select 2 again to change the connection interval. And then 3 to set the connection interval to 400 milliseconds. Hit enter. And then 1 to run the test. And then press any key. And now you're seeing the tests running. And now I just completed the test, and we see that the measured throughput is just a little over 1.3 megabits per second. And then over here we see the test configuration, MTU size, connection interval, data length extension, and the PHY setting. So there you go. That concludes the demo. Thank you for watching, and we hope that you find this demo helpful.